All right, let's get right into it. We hear so much about the massive, heavy lift it takes to train an AI model. But what happens after that? What's the point of all that work? Well, that's what we're going to talk about today. It's called AI inference, and it's the moment of truth, when an AI actually gets to work in the real world.
Right? We see these mind-boggling headlines about models being trained on just trillions of data points. But how does that actually turn into something useful? How does an AI go from being a student cramming for a test to an expert on the job? The answer to all of that lies in this process called inference.
Exactly. Think of it like this. If training is the rehearsal, inference is the big show. It's opening night. It's the moment the AI steps out from behind the curtain and has to apply everything it learned to brand new, unpredictable situation.
And at its core, it's really that simple. Inference is just a trained model looking at data it has never seen before and making a call. A prediction, a conclusion, whatever it might be. But it's doing it without an answer key. This is the AI in action.
I really like this analogy because it drives the point home perfectly. Training is that long, expensive, repetitive rehearsal process. But inference? That's the live performance, happening in real time over and over and over again for a live audience.
So to really get this, let's use another great analogy. Let's think about a busy restaurant. You've got the kitchen in the back and you've got the service area out front. Two totally different worlds, right? But both are absolutely essential for the restaurant to work.
And this breaks it down beautifully. So on one side, you have the kitchen. That's the training phase. It's where the chefs, our data scientists, are busy mixing ingredients, which is the data, using all these fancy appliances, the algorithms, to perfect one incredible recipe. That's the model. But the kitchen isn't where the customer gets the value, right? That happens out here, in the service area. This is the inference phase. This is where that one perfect recipe is used to serve up thousands of dishes, or in our case, predictions, to customers instantly. So, to put it a little more formally, AI training is that whole initial development phase. It's where the model just gobbles up enormous data sets, learning to spot patterns through tons of trial and error. It's just like that chef tasting and tweaking the recipe over and over until it's just right.
And then you have AI inference. This is phase two. The model is deployed, it's put to work. It takes all that pattern recognition it learned during training and applies it to live, brand new data to make a useful prediction. It's no longer learning, it's doing.
Okay, let's talk about the money, because this is a huge deal. Training a big model is wildly expensive. It's a massive, one-time computational cost. Kinda like building that state-of-the-art restaurant kitchen. But inference? That's a different beast. It's an ongoing, constant cost. Every little prediction uses a tiny bit of power, but when you're making billions of predictions a day, well, that adds up. It's like the restaurant's daily electric bill. And for big companies, that ongoing cost of inference often ends up totally dwarfing the initial cost of training.
All right, so that's the theory. But where is this performance actually happening? The wild thing is, AI inference is already running silently all around us in so many things we do every single day.
Let's start with a really obvious one, a self-driving car. When its camera sees a stop sign, it hasn't memorized every single stop sign in the world. No way. It's using inference to look at that new image and conclude, hey, that shape, that color, those letters, that's a stop sign. Time to hit the brakes. Or just think about your email. Every single time a new message hits your inbox, an inference model is making a split-second call. Based on its training on what millions of malicious emails look like, it decides if this new email is legit or if it needs to go straight to the junk folder.
And it's all over the world of business and sports. These predictive models are constantly running inferences. They're taking in live data, like say a basketball player's recent stats, and predicting how they'll perform in the future, all based on patterns they learned from decades of historical data.
And of course, the one we're all playing with now, large language models. Every single prompt you type into a tool like ChatGPT is an inference request. The model isn't just looking up an answer in a giant encyclopedia.
It's inferring what you mean and generating a brand new response from scratch, just for you.
So how does this hidden engine actually run? It sounds complicated, but let's just quickly pop the hood and see what's going on. The basic steps are actually pretty straightforward. It really boils down to this simple 3-step loop that just runs over and over. First, some live data comes in. Could be a click on a website, an image from a camera, anything. Second, that data gets fed into the trained model, which does its math and spits out a prediction, sometimes called a score. And third, that output gets sent somewhere useful, where an application can actually do something with it, like block a fraudulent transaction or show you a product you might like. Input, predict, output. That's the heartbeat of inference.
Now that little loop sounds simple, right? But making it happen reliably at massive scale for millions of people is incredibly hard. This is where so many cool AI projects just hit a brick wall. The whole challenge of putting a model into production is a really big deal. And this is where theory slams into reality. You need systems that are just lightning fast and that can handle huge sudden traffic spikes. Updating a model that's live without breaking everything is a super delicate process. It actually requires this whole new discipline called MLOps, that's machine learning operations, just to get data scientists and engineers to work together smoothly. And look, often the brilliant data scientists who build the model, they just don't have the specific engineering skill set to deploy and maintain it in a live, high-stakes environment.
So what's the big takeaway here? It's that while training gets all the headlines and all the glory, inference is where the rubber really meets the road. It's the non-stop, challenging, and absolutely critical process that turns a cool AI experiment into a genuinely useful tool for the world.
And that kind of leaves us with one last thought. Inference is AI in action, and there's a huge race happening right now to make it faster, cheaper, and more efficient every single day. So as the cost of making a single prediction gets closer and closer to zero, what new parts of our world are we going to be able to analyze and predict? What's it going to see for us next?